Mass and weight. Mass and weight are both related to the amount of matter in an object, but they are two different concepts. Mass is a measure of the amount of matter in an object, and it is typically measured in units of grams or kilograms. Mass is an intrinsic property of an object and is not affected by its location or surroundings. In other words, an object has the same mass no matter where it is in the universe. Weight, on the other hand, is a measure of the force of gravity acting on an object, and it is typically measured in units of newtons. Weight depends on both the mass of the object and the gravitational field it is in. Therefore, the weight of an object will be different in different locations or gravitational fields. For example, an object that weighs 10 newtons on the surface of the Earth would weigh less on the Moon due to the weaker gravitational field. In summary, mass is a measure of the amount of matter in an object, while weight is a measure of the force of gravity acting on an object. Mass is an intrinsic property of an object, while weight depends on both the mass of the object and the gravitational field it is in. The law of conservation of matter. The law of conservation of matter, also known as the law of conservation of mass, is a fundamental principle in chemistry and physics. The law states that in any chemical or physical process, the total mass of the substances involved remains constant, i.e., the total mass before the process is equal to the total mass after the process. This means that during any chemical reaction, the total mass of the reactants is equal to the total mass of the products. For example, when hydrogen gas and oxygen gas react to form water, the total mass of the hydrogen and oxygen before the reaction is equal to the total mass of the water and any remaining oxygen or hydrogen after the reaction. The law of conservation of matter is based on the principle of the conservation of energy, which states that energy cannot be created or destroyed, only transformed from one form to another. The law of conservation of matter is important because it allows scientists to predict the outcomes of chemical reactions and to determine the amounts of reactants and products needed or produced. While the law of conservation of matter assumes that the total mass remains constant, it does not take into account any changes in the energy of the system, such as the release or absorption of heat or light during a chemical reaction. However, the law remains a fundamental principle in chemistry and physics and is widely used in many scientific and engineering applications. Apply the law of conservation of matter. The law of conservation of matter can be applied to any chemical or physical process to ensure that the total mass of the substances involved remains constant. Here are some examples. In a combustion reaction, such as burning wood, the law of conservation of matter states that the mass of the wood before burning is equal to the mass of the ash, smoke, and gases produced during burning. In a precipitation reaction, such as mixing silver nitrate and sodium chloride to form silver chloride precipitate and sodium nitrate solution, the law of conservation of matter states that the total mass of the reactants is equal to the total mass of the products. In a nuclear reaction, such as the decay of uranium-238 into lead-206, the law of conservation of matter states that the total mass of the uranium atoms before decay is equal to the total mass of the lead atoms and any particles or radiation emitted during decay. In a chemical synthesis reaction, such as the production of ammonia from nitrogen and hydrogen gas, the law of conservation of matter states that the total mass of the reactants is equal to the total mass of the product ammonia. By applying the law of conservation of matter, scientists can predict the outcomes of chemical and physical processes and ensure that mass is conserved in all reactions.